welcome to a future where AI is going to redefine how you will perform hematology, how you will perform medicine. My name is Koen. I'm a former molecular oncologist who turned digital and who had the luxury with a fantastic team to develop humanized antibody to treat brain cancer in children. But in all honesty, the best thing we could do is sending these kids on a camp. And that camp was called Camp Delight. And these two words, digital delight, became my North Star. Can we make a healthcare system which is so delightful that care is something I look after and where digital is completely hidden and helps us to redefine how we treat patients and how we manage to run a pharma company. Now, I don't think we have experienced the discovery of fire and the wheel, right? A number of you have seen the introduction of the smartphone. And yet, for me, the biggest invention ever is soap. Soap managed to extend our lifespan with 100% in something like 150 years. I think that AI has the same power to completely redefine how we as human beings are going to live life on Earth. And therefore, I think it's the best of time to live, but only if we are not too busy to see it. And if we are not saying, well, let's see what happens in the future. So I hope that this will help to inspire you as a patient, as a care provider, as a hematologist, as a pharma drug developer, to really say, well, let's experiment, let's explore, and build the world together from a white page, right? That's what we're going to try to do. Now, I fully realize that a number of things I'm going to show are pretty dystopian. When I showed my daughter that I can tell how she will look in 50 years, she didn't like it. Till she kind of thought, well, wow, if I can do that, if I can anticipate things from happening, well, that gives me superpowers. Imagine as a doctor, as a pharma developer, you have superpowers to know what is going to happen the day after tomorrow, and you can do something with that. Look to this. This is the Last Supper. We have technology now which can ask, what would have been painted if the painting would be bigger than this? And all of a sudden the computer, using something called DALL-E, says, well, this could have been the picture. This has never been painted. This is basically created by a computer algorithm which says, maybe this is it. So if this kind of creativity is really true, well, how will you use that as a chemist, as a drug developer, as a doctor? So what if you start to ask, how would a next generation anti-CLL, anti-leukemia lymphoma drug look like? And not surprisingly, we start to see the first examples of artificial intelligence, which is using the same kind of algorithms to ask a computer, make me a painting, or find me something, whatever, in a pile of texts, make me a medicine we've never seen before. Dream up the best way to treat lymphoma. And that's pretty kind of scary on one hand, because even scientific research starts to be AI'd. And we start to see that the first experiments to synthesize drugs, where basically I don't need a big physical lab, but where I need a number of computers, start to take place. Not today, maybe not tomorrow, but keep in mind that this is something we might still need, except if we can do better. And that better I'm going to try to show you. I think we're going to build a world in which you as a doctor, you as a care provider, will use technology to become a real superhero. So this shouldn't frustrate you. This should really be something you endorse, you basically bring on in your practice to become a better care provider, and at the end, to help me as a patient in a completely different fashion. Now, AI is not something novel. Basically, the first time the term was used was 55. And basically, artificial intelligence is simply statistics on steroids. Nothing else. It's basically doing regression analysis, trying to find relations between number of data. And in the big pile of artificial intelligence, a number of years ago, when computer power went up, and when the number of data sets available went up, we started to see something called machine learning and something we now call deep learning, where basically, in machine learning, we taught the computer something and said, well, we discovered this, and now, with really big data sets, we can ask the computer, discover something we might have not been able to see ourselves as a human being. And while you have seen a number of applications like the analysis of X-rays, of images, and the analysis of cancer growth in images, and the prediction algorithms to say, well, this patient might require care before someone else. I think the real acceptance of introduction of AI was the time, November 22, when something called ChatGPT became almost a household name, right? I'll go into detail, but ChatGPT I'm going to use as kind of the umbrella term for large language models, excuse me the term, or foundation models. But I think it's relevant to put the terms and coin the terms, because they will be fundamental in how you perform your future career. November 22 launch, March 23 already, kind of the next level of ChatGPT called GPT-4. And these two things might reappear a few times. And basically, what these things do is simply not being my brain on steroids. It's basically a computer, a number of computers linked to each other. Yeah? What ChatGPT does is super simple, a tool to do search on steroids. Nothing more. I will really try to balance the excitement and the power of things I'm going to show with a number of things where we are not there yet. And this is the stone age of AI. But the reason that I showed you a very weird, very colorful picture as the first slide has a reason. Because I'm going to show you what I asked to make that picture 3 months ago and what I asked to make that picture yesterday. The difference between the two pictures is pretty telling in the power of progress in that kind of AI. So what ChatGPT does is super simple. It is collecting a huge amount of data, puts them all together in a large language model, and allows you to ask questions based on text, on images, on voice, on whatever. And if I have to dissect it into, well, a very technical kind of slide, it's basically all the data ever published on the web put in one big bucket. And if you ask a question to that big bucket, what it does, it cuts that question into pieces of tokens, 1, 2, 3, 5 digits. And it simply looks whether your tokens, your pieces of letters, are somewhere present in that big pile of information to come up with an answer, seemingly a correct answer. But that's no ideation. It doesn't discover something. It just looks for the right setting and the correct kind of analysis of text behind each other. What was exciting, though, is that while things like Netflix took 10 years to reach 100 million users, or TikTok took 9 months, ChatGPT had 100 million users in just 2 months. We've never seen that on planet Earth. So the people who are not using it yet, I think it becomes time just to explore with it, just to find out what it could do for your kind of citizen life, right? And by the way, these things, these chatbots, it's not just ChatGPT which is there. All the big companies are making them. By the time this goes live, it might be that there is something from Google called Palm 2, which does do better. And that's something from Google as well. Bart is even doing better. But the context of these chatbots, which use large amounts of data, that will continue to happen, right? So don't bother too much about the names of all these bots, but bother about what can I do with them in my practice? What can I do with them in my company? What can I do with them for me as a patient? So we started to explore with these things when they come out. So what you can do now is ask, you can show me a picture, and the computer tells me, wow, I see a brain with a number of subparts, and I'll explain you what these parts do. Apply that to a scan from pathology. And the computer can analyze in all these images that some images seem to be different from all the rest, and that they have been found in a kind of tumor called diffuse large cell B-cell lymphoma in the past. So all of a sudden, the computer tells you what you cannot see as a human being, but helps you detect something new. And obviously, you will have been exploring things like this. I'm a hematologist. Can you explain how ChatGPT will change how I treat and manage my cancer patient in the future? And it looks in all the current knowledge on how that could be done and gives you quite a decent answer in just a few seconds. I can do it in whatever language. Explain me the diffuse B-cell lymphoma in Dutch. or in French, or in whatever, Arabic. And in 5 seconds, it does that for you. Or explain me diffuse large cell B-cell lymphoma in the style of Eminem. And it makes you a rap song, not kidding. Whatever who you think can ask something, you can provide the computer as input. And all of a sudden, you have new ways to start communicating with your patients, right? And that's what I'm going to show you where we are going now with the next generation of all these bots. So these things can be used to start looking into not just a small amount of material. I can provide my full medical dossier, my full medical record, 50 pages, part is handwritten, part is text typed, and it provides me a summary in half a page. So I no longer have to think, in a sense, to look through all these things. If I can trust at some point that this technology is feasible to use, the amount of time I gain by using this is almost incomprehensible. It gives me a 100-fold increase in execution power. So if that ChatGPT thing can summarize a PDF with my full profile, can it summarize a clinical trial? And unfortunately, we're not there yet. I tried. April 13, I looked in one of the AbbVie trials and asked, well, what is this trial about? And he gave me a small summary. But I said, I knew it was what it was about. And I said, well, but you're wrong. And the computer said, well, I apologize for the confusion. That's not something you want to encounter if you deal with your patient, right? So I asked again, well, you're still wrong. And again, he said, I apologize for the error in my previous message. That's a concern, right? So there is kind of a reason to believe that we have to find out where it's good for and where we have to define where it's not good at. So it hallucinates, really. It can even define a paper, a reference, combining two existing references from the past, and it seems that by putting them together, it's an existing reference, but which was never even published. And that is something we need to get right. So these kind of AI algorithms, they have biases, they make mistakes, they provide sometimes not the right information, and do even worse, they disinform you. So how do I deal with these things? Because if I start to use it, it seems that it comprehends, and it provides answers in different variations, and that's why it seems to have full cognition of what I'm asking. And that is where the majority of people are mistakenly. So there is a big difference between comprehension and cognition, right? Comprehension we can do now. Cognition, we're not there yet. And that is the big future for the next months and years, where I think we're gonna see AI becoming really an extra brain, which can reason, which can create really novel ideas, and which even seems or will have the seemingly power of being ethical and moral. And that's where we're gonna start seeing super exciting things. And that's where we're gonna have to ask ourselves, how can it make us better doctors? How can it make us better pharma developers, right? So what are the benefits, the limits, and the risk of using the chatbots? Well, companies haven't stopped or haven't waited till we find out. In less than 3 months, we've seen 15 companies basically entering the market, which allow you to do a pre-visit to me as a doctor. And so I can ask a lot of things which diagnose me, and basically I come to my doctor basically for a second kind of confirmation. I don't have to spend the time as a doctor to do a big part of the research. The computer has done it for me, right? And that's not just Dr. Google any longer. This is looking into my medical record. This is looking into the data who define who I am, right? So if we can start to see these things happening, wouldn't that be logical that you as a doctor, who is not always present for me, that we can also digitize you? And that, for instance, you as a doctor, that I can make basically an avatar from you, which can talk to me for the time that you don't have time to see me, but where I can ask all the questions I have about how my treatment will work, about how you will take care for me, about how you will explain or help me explain to my parents that I have a cancer and that I might die before they die. And all of a sudden, I can start to become a more empathic doctor. A doctor who can start to do a number of things in parallel with the newest kid on the block, which is called AutoGPT. And AutoGPT allows me to ask something and execute it. Let me show you. Imagine that I ask, how should I explain to a 6-year-old that she has a lymphoma? And so the computer comes up with a number of ideas. You can make it a game. You can provide an adventure to discover what the tumor really means. And I'm saying, well, wow, pretty cool, but can you help me with doing that, executing on that? And simply with one button, my computer tells me, yes, I can develop you a game. I program a game in a piece of software, and I build you a 3-dimensional world in which your kid is gonna learn what a hematology, what a lymphoma really means, and why being on a drug is something you have to do in an adequate fashion. Because if you do not continue treatment, you will lose. And that kind of entire story, we can start to build for you. You can start to build yourself. So by the time you're gonna launch a new drug, how cool would it be that that drug is launched not just in the analog world, for sure, but also in a virtual world, always on, 24/7, where I can ask, whenever I have the time and I'm having the mental power to deal with the fact that I have a cancer, but that you're going to treat me, that I find spots anywhere on the planet where you as a doctor are available to explain me what is going to happen with me. That is, I think, what you as a company, what you as a hematologist will and should do, being present for your patient 24/7. So if we are able to do that now already, what is the future? Well, I think a few things. We're currently aware of 6 parties which are developing next generation GPT-4. I don't know what the name will be, GPT-5, whatever, but we start to see what the power of these things could be. This is one of them. In the future, we will be able to ask, make me a molecule which has a chemical profile, and look to all the genetic profiles from all the bacteria we've ever seen, compile me a bacterium which synthesizes that chemical molecule. That's a pretty cool question, right? That is exactly what we do now, asking, well, what should I ask my children if they tell me that they don't know how they have to treat me for my birthday? That is a pretty cool question, if I can do that and get an output. Or this one. We always have believed that men are empathic, machines are not. But we've seen the first results, that patients which got asked questions to a real doctor and to a computer, that they found the replies on par, and that sometimes they found the replies from the computer even more empathic. On one argument you will say, well, that's nonsense, but turn it around. Because if that is true, then you can use all the power of the machine to make sure that you use all your power as a human being to treat me well. And for that reason, you never should spend time in doing things the computer can do faster, better, and more kind of in a pragmatic fashion. And that is the reason where you're going to start to see things combined. A super busy slide on purpose. But one of the things you really have to read, published just a few weeks ago, was a Nature paper, where we start to see that if we can get all these large language models, which currently collect all data from the internet, well, why don't we use them to collect all data from my patients? My medical data, my real-world data, my social status, my whereabouts, my environment, what I eat, all these things together. And we start to use them to think, well, if that defines who I am, for instance, this defines who I am. I live in London a few months a year. I know how many steps I take. I know which temperature there is, how many pollen there are. I know which measurements I take. I do basically know a lot about myself. I collect all this data in a large language model, in one box, which defines who I am. And so if I am able to define who I am, I can make a digital version of myself, a so-called digital twin. Why? Because I know what defines me today, so instead of starting to tweak on me, on a real human being, imagine that you can start to test your new molecule, your new treatment, your new prediction trial, not on me as a real human being, but on a piece of software, on my digital twin. And in 2023, for the first time, we start to see that it becomes feasible to build digital twins of humans. so that you as a doctor have way more insight in who I am, because you will have access to my 24/7 data and will be able not to spend time in finding out who I am, but being an empathic interactor which takes me through my disease. And so if I have to summarize, what I think the real future of AI is, it's basically a summary like what Big Hero 6 showed you. A future where 5 friends get to know a 6th marshmallow inflatable doctor, Baymax, who lives in a very small box at home, and it says AbbVie, and now and then, ploops, it appears out of the box and gets all the data who define who I am, my genetic data, sensor data, to link them all together and to make machines smarter, to make machines more intelligent, and to use that artificial intelligence, all called, to change something in my action, something in my behavior, and to provide me a delightful way to deal with my disease. And if that is true, knowing that the picture you've seen on slide 1 at the left was what I asked the computer, show me a tumor cell attacked by an immune cell, and that is how it's being graphed today, then I think that with a few things which I've shown, that they will take you into an inspirational session, asking yourself, playing with it, how will I use AI to become a better doctor, a better drug developer, a better care provider, and how will I delight my patients today, tomorrow, with artificial intelligence and digital technology. Thank you so much.